Now we're going to talk about the importance of the parameters of the exponential function that I have just showed you with word problems. I want you to remember what a and c are in y is equal to ac to the x. So remember that a is the initial value of the function, where the function begins, where it crosses or lands on the y-axis is a. It's the same thing as the initial value in y is equal to ax plus b, where the function crosses the y-axis. So if you remember your linear function, b was where it crosses the y-axis, that was your initial value. C is what the y values are multiplied by, always when x is going by increments of 1. And that's how you figure out what your C is. I hope you recall your table of values that I've given you on your quiz. C, therefore, is also known as the rate of change of an exponential function. So it is the equivalent of what a is in the linear function. Because I've been talking to you a lot about linear functions, I just want to review the word problems that we looked at the beginning of the year with linear functions. Here's an example. When a psychologist receives a patient, the patient needs to pay an initial cost of $20 for services plus additional $40 per hour for the psychologist. Do you remember these types of questions? I think I gave you one on the taxi driver. How do I take this word problem and convert it into a linear equation y is equal to ax plus b? It's simply y is equal to 40x plus 20 because the initial cost was $20, so that's our plus 20. And the additional $40 per hour is our 40x, where x is the total number of hours. And if we were to calculate what x would be depending on the number of hours, y would give us the total cost of the psychologist. So for example, if you were going to see a psychologist for 2 hours, you would put that into x, you'd get 40 times 2 plus 20, and that would give you the total amount that you would have to pay to your psychologist. I want you to remember this as we go into the upcoming slides, remembering that just like a linear function, your exponential function does have an initial cost, and it does have some kind of rate of change. I'm going to introduce you to the word problem that we are going to solve in this PowerPoint. And as I go through the PowerPoint, you will always be reminded of this word problem. Your word problem is, bacteria grows by 12% every hour. If at the start there are 100 bacteria, how much bacteria will there be after 4 hours? So with this question in mind, I'm going to teach you how to answer it. There's another way of looking at the original rule y is equal to acx. When you solve word problems, you can take that function rule and you can read it as y is equal to start times change to the power of time. And I'm going to explain what each of these things means. So in this case, when you have a word problem, a is the start, also known as the initial amount of the word problem, where the word problem starts. In this case, the one that I've given you, the initial amount is the initial amount of bacteria. How much bacteria is there at the beginning of this problem? C is change, or growth, or decay. It can be represented as increasing, decreasing. In our question, it's how much the bacteria grows. So we're talking about an increase. X is usually, mostly always, the time after the initial time that you start your question. In this case, it's 4 hours after the start. And Y is the ending amount, in this case, of bacteria. So how much bacteria is there going to be after 4 hours if we started with 100 bacteria and we know that it grows by 12% every hour? How do you solve a word problem? To complete a word problem belonging to the exponential function, you actually need to find the rule y is equal to ac to the power of x using the information from the last slide and from the question being given to you. Try to start by identifying a, your initial amount, then determine what c is, growth or decay, and once you determine the rule with a and c, you can use any x for hours or any y for bacteria to be found. Let's start with finding a. A is the initial value or the start of the function. In this case, how much bacteria was there initially at time 0, say. If at the start there is 100 bacteria, therefore there are 100 bacteria at the start. We already found A. So now we're going to talk about how you find C. C is the change in the growth or decay of the subject in your word problem. There are some tricks, first of all, when you want to find C. The first trick is if the word problem says something like the population is doubling, C is just 2. If it says the population is tripling, C is 3, and so on and so forth. Sometimes the change is given as a percent. For example, the population increases by 15%. The bank wants 14% interest. The animal population is decreasing by 16%. You would assume that you just take that percentage, but that is not the case. When you are given a percent in a word problem, you must use this rule in the corner. You must change your percent by making it 1 plus or minus that percent over 100. We use plus when our function is increasing, so when there's a growth. If it's decreasing, if the population is going down, we use the minus. Now you know those 2 rules. Can you determine whether our word problem is growing or decaying, and if so, how is it given? Let's read the question in the corner. Bacteria grows by 12% every hour. Our bacteria is increasing, it's growing, and it's also given as a percent. We have to remember this rule. When we are given a percent, we have to change it as 1 plus or minus that percent over 100. And because ours is increasing, we are going to add it together. Therefore, we'll have C is equal to 1 plus or minus 12% over 100, but in our case, it's going to be plus. 12% over 100 is simply 0.12. And if we add a 1 to that, we get 1.12. C is 1.12, so our rule becomes y is equal to 100 times 1.12 to the power of x. We have the word problems rule in the corner there, y is equal to 101.2 to the power of x. The question, though, says to us, how much bacteria will there be after 4 hours? Remember that I've already mentioned this to you in a few slides earlier. X is always time, usually the time before or after the initial time. So for example, 3 hours after, 50 seconds later, 9 months before. What's important though is that time has to be the same unit. In our case, time is always given in hours. 12% every hour, after 4 hours. This is good. If the time was not the same unit, you would have to convert to one same unit. For example, if you were given 12% every second, how many bacteria will there be after 4 hours? You'd have to change it so that it's the same unit. Hours, minutes, seconds, months, no matter what. In this case, y is the total number of bacteria and x is the time, and they say after 4 hours, so we will have y is equal to 100 times 1.12 to the power of 4. And if we do this, 1.12 to the power of 4 is 1.57, and if we multiply that by a, which is 100, we get y is equal to 157. After 4 hours, there will be 157 bacteria. Here are things that I want you to remember when you solve word problems. First, you have to recognize that this kind of word problem is an exponential function. They all look the same. Currently, the one that we are looking at is y is equal to ac to the power of x. Always check your initial value as a times 0 of the word problem. So in our case, it was 100. It started at 100 bacteria. C is your rate of change. So check and see if your question is saying if it's growing, if it's decreasing, if it's increasing, and sometimes it's given to you in percent. X is the time before or after the start of your function. For example, if you start your survey in 2000 and you want to know what your survey is going to be like in 2010, you know that 10 years went between 2000 and 2010, and that is your X. Always make sure that it's in one unit. If it's all in hours, if it's all in years, if it's all in months. And Y is always the total number of the subject in the word problem. Our subject was bacteria. Sometimes we'll get population and sometimes we'll get interest. Please remember that if your growth or decay is a percentage, you must do the following. You must convert it by doing 1 plus or minus that percent divided by 100. And you need to recognize when it's increasing, so you have to do plus, and when it's decreasing, so you have to subtract. Try this on your own. Identify the equation in y equal to ACX form, then answer the question. So I'm going to give you the question. I would like you to pause the video in this case and try this question on your own. Each year, the frog population of a small wooded area declines by 5% in contrast to the previous year. If this wooded area has 2,000 frogs, how many frogs will be present in 10 years from now? Try this question on your own. Identify the equation in y is equal to AC to the x form and then answer the question. The population of the popular town of Smithville in 2003 was estimated to be 35,000 people, with an annual rate of increase growth of about 2.4%. What will the population be in 2007? That is the end of this presentation. The next thing that we're going to be learning is y is equal to AC to the power of bx.